module is for the chemistry general student, chemistry CEMG, chemistry general students under the WBSU. That means West Bengal State University. Okay. This is for the same one students. Now the paper code is CMG COR 01T, and it is also applicable for CMG COR 01P. Okay. So this is a common e-module for the theory paper and the practical paper. Okay. Now in your theory paper there is a portion in group A. There is a portion in group A in unit 3, that is the Redox. Okay. So today we are going to discuss about the basic fundamental things about the Redox reaction. So what is Redox reaction? The term Redox means reduction, and OX stands for the oxidation. OX stands for the oxidation. Okay. Now here we are going to define these two things, these two reactions, reduction and oxidation, in terms of electrons. Okay. So what is reduction? What is reduction? Reduction means if some species like this, if some species takes electrons and accepts electron, then this reaction is called the reduction reaction. Okay. And the oxidation is just reverse. Oxidation is just reverse. If some species give up electrons, of course, like sodium atom. If it is give up electron, then it forms the sodium plus and one electron. If the electron leaves out from any species, then it is called the oxidation. So it is oxidation reaction, and this is the reduction reaction. Okay. So in the reduction reaction there is a gain of electron, and in the oxidation reaction there is a loss of electron. And you can see in the oxidation reaction the oxidation state is increased. Where how we can see this? Like in sodium is a free metal atom. Free metal atom means its oxidation state is 0. So here 0 to plus 1. Change is 0 to plus 1. So in oxidation, always in oxidation, increase of oxidation means increase of oxidation number. Increase of oxidation number. Okay. And the reduction, here you see here, it is also a free chlorine atom. Any free atom means its oxidation state is 0. So here 0 to, the change is 0 to minus 1. So here decrease. So in reduction, what's happening in reduction? In reduction, decrease of oxidation number. Decrease of oxidation number. Okay. So today we are going to a real system where we can see someone is oxidized and someone is reduced in real system. Okay. And you can see here, always we say that reduction and oxidation happens simultaneously. Okay. Why? Because in reduction some species gives up electrons, and there must be some oxidation who gains that electron. So always reduction and oxidation, these two reactions is going simultaneously. Therefore, as a whole, we say it is a redox reaction. It is a redox reaction. So today we are going to discuss about a real redox reaction, when some species is oxidized and some species is reduced simultaneously. So here in your this paper CMG-COR01P, in this practical paper you have a estimation of iron 2 by potassium dichromate. So we are going to do this practical here. What? The title of our practical is the estimation of estimation of iron 2. Okay, estimation of iron 2 by estimation of iron 2 by P2Cl2O7 potassium dichromate. So here estimation of iron 2 by potassium dichromate. Okay, so what's happened here? Here we take iron 2. We are going to estimate iron 2. Iron 2, iron is 2 plus, iron 2 means iron 2 plus, iron 2 oxidized. Here this is a potassium dichromate. By this reagent, potassium dichromate oxidize iron 2 to iron 3 plus. Iron 3 plus. So iron 2 plus oxidizes to iron 3 plus. As I told you just now that 2 plus to 3 plus, it is an increase of oxidation number. So of course it is an oxidation. It is an oxidation. Okay. Now here it is oxidation. That means oxidation means some electrons is out from the iron 2 plus. Okay. Some electrons is out. So here we keep it in plus in here. Okay. So now iron 2 plus is oxidized to iron 3 plus. Okay. Now who is reduced here? And for this oxidation, potassium dichromate, as potassium dichromate oxidize iron 2 plus to iron 3 plus. So what's happened with potassium dichromate? Here potassium dichromate, this is the main dichromate ion. So here Cr2O7 2 minus, here it is chromium goes to chromium 3 plus. Okay. Here the chromium oxidation number of chromium is plus 6. Plus 6 to changes to 3 plus. Okay. Plus 6 changes to 3 plus. So here the oxidation number is increased. Increased not, it is decreased. So here plus 6 to plus 3, it is decreased. So it's a decrease of oxidation number, so it is a reduction. Reduction. So how it is reduced? How this dichromate reduced to chromium 3 plus? Obviously it takes electron. It takes electron and reduced to chromium 3 plus. Okay. Now, so these two reactions happen simultaneously. This is oxidized and this is reduced. Okay. It takes electron and it gives electron. So this reaction is happen simultaneously. So the main reaction is dichromate oxidized to iron 2 plus and makes iron 3 plus and itself reduced to chromium 3 plus. Okay, itself reduced to chromium 3 plus. This is the main reaction. It is the oxidation and this is the reduction. So these redox reactions happen simultaneously. Dichromate is called the oxidizing reagent. Why it is called the oxidizing reagent? Because dichromate oxidize iron 2 plus to iron 3 plus. Okay. So here we are going to see this reaction. What is happened, and with the use of this reaction, how we can estimate iron 2 plus. This is we are going to see. Okay. So we are taking two solutions here. One is iron 2 plus solution, another is dichromate solution. One is iron 2 plus solutions and another is the dichromate solution. We are going to see the method is the dichromatic method. Okay, this dichromatic method. Dichromatic method means we are going to do the titration. Titration, iron 2 versus potassium dichromate titration. Here we are going to do the iron 2 plus versus potassium dichromate titration. Okay, and indicator. We know that we need indicator for any titration. Most of the titration we need the indicator who change its color and show the end point. Here we are going to use the redox indicator. Why redox indicator? Because it is a redox reaction, and for any redox reaction we need a redox indicator. Here the indicator, that is the redox indicator. Name of this redox reaction, redox indicator is BDX. Okay, BDX means barium diphenylamine sulfonate. This is the indicator. This is the redox indicator. This indicator name is barium diphenylamine sulfonate. You can search it. You can search it and see the structure of this indicator. Okay. So this is the redox indicator. What we going to here we going to use. Okay. So this is our task. We are going to do a titration. This titration is iron 2 versus dichromate titration. We are taking iron 2 plus in the conical flux and dichromate in the burette, and then add the indicator, BDS indicator, and for this proper reaction we maintain a acidic pH. Therefore, this reaction is happening in the acidic pH. Therefore, we have to use some acid in titration, during the titration. Okay. So we are going to do the titration. It is the iron 2 versus dichromate titration. It is a redox titration. You can see the redox reaction. This reaction happened here. Okay, dichromate is reacting with the iron 2 plus and makes iron 2 plus to iron 3 plus. Now there is a problem, that is iron 3 plus has a distinct yellow color, and this color, we know this indicator means how indicator indicates the color, indicates the end point. We know that indicator ends the indicate the end point by changing its color. So, but here is a problem is iron 3 plus, when we are going to do the titration, you know there is a redox reaction. We add dichromate and here in conical flux iron 2 plus is present. So continuously iron 2 plus is converted to what? Converted to iron 3 plus, and a yellow color is generated. And for masking this color, so that our indicator works properly, for masking this color, we are at ammonium bifluoride, this reagent, ammonium bifluoride. Okay. So what are the things we are going to add in the iron 2 plus solution during the titration? First is the acid for maintaining the proper pH. Second is the ammonium bifluoride for masking the color of the yellow color of the iron 3 plus, so that we can get a proper end point. And number 3 is the indicator, that is the BDS indicator. Okay. So this is our work. We are going to do the titration. So let's start the titration. First of all, I hope you can see this is the potassium dichromate solid. Okay, the orange color crystalline solid. This is potassium dichromate, and this is the salt, iron 2 plus salt. But we are making with this salt, we are making a solution, iron 2 plus solution. Okay. So by using these two solids, we make with the distilled water, we make the potassium dichromate solution. Okay. And it is a N/20 potassium dichromate solution, and this is the iron 2 plus solution. Okay. So how much iron is present in this solution? We are going to estimate by titrimetric method. Now first of all, what we have to do, we fill the burette. Okay. We fill the burette. We fill the burette with the potassium dichromate. Let's start. Fill the burette with potassium dichromate. We fill the burette up to the mark. Perfect. So it is potassium dichromate. I fill the burette with the N/20 potassium dichromate solution. Now I have to pipette out. the iron solution. Okay. So with this pipette, it is a 25 ml pipette. So I try. So very careful when you whip it out. So it is your up to the mark. Okay. Now take it in the conical flask. So this is your iron 2 solution. Now we have to add 25 ml. As I said that for this titration we need a proper condition. For this titration it is happened in the acidic pH. So we need a acidic pH. So we add 25 ml 4 normal H2SO4. This is 4 normal H2SO4. We add 25 ml 4 normal H2SO4. Okay, it is approximately, I am using the measuring cylinder. That means it is approximately 25 ml. Okay. So here we put it into the conical flask. Then as I have said that when the reaction is progressed, then iron 3 plus is generated, and iron 3 plus has the yellow color, and this color can be maybe interfere with the color change of the indicator. So proper endpoint we marks this color. For marks this color, we just we add approximately 1 gram ammonium bifluoride. Okay, it is approximately 1 gram. It is, you can see it is a white crystalline solid. So I add this. So here iron 2 solutions, and then 25 ml 4 normal H2SO4 solution for maintaining the pH, acidic pH, and then I add the 1 gram, approximately 1 gram ammonium bifluoride, which marks the iron 3 plus yellow color. And then we add redox indicator. This is a BDS, barium diphenylamine sulfonate. We add this in 4 to 5 drops. Okay, and then this indicator, and all is here. Now we start our titration and let's see what's happened. So we are expecting some color change here. Okay. Already the local color is coming. I don't know you can see or not in the video, but a local color is coming here. And whenever some local color is coming, then we are sure that we are in the right way. So a local color is coming, and we are waiting for the full color change. Continuously shake it. You can see a color change, a greenish color change. Okay, green because dichromate is converted to chromium 3 plus, and chromium 3 plus has the green color. So you can see the green color of chromium 3 plus, but this is not our end point. Okay, so we are, I hope you can see the color change, because it's a very good color change, distinct color change. The reading is, just proper way is out the bullet, and then you see the lower meniscus. Lower meniscus is 23.3. So our reading is 23.3. So we need this reading for our calculation. Now we go for our calculation. Okay. So the reading is, our reading is 23.3. I just check it again. Okay, it is 23.3. So the reading reading is 23.3 ml. So we take 25 ml iron 2 solution. So for 25 ml iron 2 solution, the reaction tells us that this titration tells us that it takes 23.3 ml dichromate solution. So this is our reading, 23.3 ml K2Cr2O7 solution. Okay. Now we go for the calculation. By this calculation, we can say how much iron 2 plus is present in my sample in this solution. So we go for the calculation. Okay. So we know that 1000 ml 1 normal K2Cr2O7 equivalent to 55.6 gram of iron. It is the molecular weight of iron. So 1000 ml 1 normal dichromate equivalent to 55.6 gram of iron. Okay. So our reading is 23.3. So our reading is 23.3 ml, and we know we are using in very beginning I have said that we are using 8/20 K2Cr2O7. The strength of K2Cr2O7 is 8/20. We are using this strength of K2Cr2O7. So 23.3 ml 8/20 K2Cr2O7 equivalent to 55.6 into 23.3 divided by 1000 into 20. So this is our calculation. Half a gram iron is present. Okay. Now I am using the calculator and see the calculation. Okay. 55.6 into 23.3 divided 20 divided this calculator shows it is 0.065. It is 0.065 gram iron. Okay. So it is iron 2. It is iron 2. It is also iron 2. So in my sample, I am pipetting out 25 ml. So in 25 ml sample solution, this amount of iron 2 is present. Okay. So I am writing this in 25 ml iron 2 solution. 0.065 gram iron 2 plus iron 2 is present. Okay. So in 1000 ml, we are going to calculate for 1000 ml, that means 1 liter. So in 1000 ml iron 2 solution, how much iron is present? 0.065 into 1000 divided by 25 gram iron 2 plus is present. So I use the calculator and see the result. It is 0.065 into 40. That is 2.6 gram. 2.6 gram iron 2 is present. So this is our conclusion. By this way, we can estimate the iron 2 plus by the titrimetric method by using the potassium dichromate solution. So here, it is our conclusion that 2.6 gram per liter because 1000 ml is 1 liter. So 2.6 gram per liter iron 2 plus is present. Okay. So this is all about the, by this way we can estimate iron 2 plus by potassium dichromate solution. Okay. So here this is all book by I. Vogel. It's the Analytical Inorganic Chemistry books by I. Vogel. You can get this method, this work there. Now, I have a questionnaire for this. Okay. So this is for you. You can solve this questionnaire and send it to me. Okay. So this is for you, a questionnaire, and you can give your feedback in my in my mail ID. This is my mail ID. mobidabrSC@gmail.com. Okay, you directly send it to me. This questionnaire is for you. This feedback you can send here. Okay. So number 1, what is redox reaction? What is redox reaction? I hope after this class you can able to answer at least some of these questions. Okay, and you can see yourself that how much you can answer these questions. What is redox reaction? Give some example. Give some example. Okay. Number 2. Balance the following reaction. Balance the following reaction. Balance the following reaction. I am using this reaction. Okay. I did not balance this. You just yourself you try to balance this reaction. I know 3 plus 2 here 3 plus. Okay. So balance this reaction. Then number 3. What is indicator? What is indicator? Explain with example. What is indicator? Explain with example. Okay. Then number 4. Number 4. Give the full name and structure of BDS indicator. Give the full name and structure of BDS indicator. BDS indicator. Okay. And the number 5. That is, if this is a question you can find out yourself, because this is also here, but I am not indicating. So this is you search yourself. What is the primary standard solution? What is the primary standard solution? What is the primary standard solution? Give example. Okay. I am using a primary standard solution here, that is potassium dichromate. Here potassium dichromate is the primary standard solution. So you have to find out or search what is the primary standard solution and give some example except the potassium dichromate. This is the this is the questionnaire for you. You can give this feedback to me. Okay. And if you have any query about this e-module, then you can also send your queries directly to me. Okay. So I hope you enjoyed the class and thank you very much.